let's get started. The prompt is posted in the main channel, and we'll do the discussion in the thread. And today, why don't we start with Naichi and go up, Mayor, Jenna, and so forth and around. So, Naichi, take it away.
Hello, hello. Am I heard?
Yes.
Okay. So the basic explanation of things, I think it's the CICERO project is kind of a low resolution demo of AI doing social stuff. So it's basically not enough resolution to fully say that it is doing real social things. So the title says about negotiating, persuading, and cooperating. I think it's a bit of a overstatement here. So I feel like it's like we're in physics class and we're talking about the spherical cup, like something like finite element analysis. It's only a few elements in the game. So it's not much, but I think they will probably progress enough so that there is actually some finite element analysis type of development that goes on in this front. And it will encounter kind of the similar problems with finite element analysis, such as the problems that happen when compared to reality, I think. And is there a step? I think there's a Medium post on what the model did in a step-by-step basis. I think I can share that in the Discord link, Discord channel. Wait a minute. So in that link, there are 4 steps that is states of the CICERO model, and I'm kind of focusing on step 3 and step 4. Step 3, it says CICERO generates several candidate messages based on the board stage dialogue and its intent. And step 4, it says filters the candidate message to reduce nonsense, maximize value, and ensure consistency without intent. I think step 3 and step 4 are kind of misplaced in in relation to how you actually think about things. I think I don't think we filter out the candidate message at the last step. I think it's like every step we filter out candidate message to reduce nonsense. So yeah, I think it's a low resolution demo, and generalization will take some making everything continuous, I think. That's about it.
And we're passing upwards today, so Mayor is next.
Thank you. So before I say what I think about this paper, I have a little bit of history here. My advisor for my PhD, which I never finished, she got her PhD in the end of the 80s, early 90s, for writing a program in Lisp that negotiated and would win games in diplomacy. Unfortunately, it was on tape, and you can imagine what happened to the tape. And there was a printout, and you can imagine what happened to the printout. So people doing AI to negotiate against other people and win diplomacy has been going on for, I don't know, 30 years at least, 35 years. I myself wrote a paper which was chat, but only in the sense of having 2 rounds of talking, and only with one person, but again, using all sorts of methods to persuade humans to make the right choice. Right meaning it's good for the AI and bad for the human. So my advisor had opened a whole center, the focus of which was AIs talking to people and how to help people, persuade people, negotiate with people, and so on. So that's just history. But when I read this paper, the question I'm asking myself, and I think you must read that article that Ben posted by the Tzvi, where he really explains the difference between what the title says and what they were actually doing, which is perhaps less, perhaps more. But the question I'm asking myself, does this Cicero understand the strategic situation? Okay, so diplomacy is supposed to be a game of strategy. And does it understand the strategic situation? And I know you can ask the same question about the DeepMind Go game, which perhaps doesn't understand anything. But nowadays, we have chat interfaces, and Cicero can explain what it did and why it did. And of course, it might be lying or hallucinating, but I'm still wondering, what does it mean when we say Cicero understands and can explain the strategic situation and what things it can do, and, what acts it can come out. Now, when I look at the order of the steps, it seems to me that it doesn't understand. And the reason why I'm saying that is because it generates several candidate messages based on the board state dialogue and intent. I don't hear strategy, I hear at most some taking advantage of tactical opportunities. Perhaps some strategy happens in step 2 at the beginning, but that's not clear. So when I get back to the question of whether it might generalize to other general social coordination situations, and having read the articles that Ben posted, I think the answer is no. I think it's doing too much of predicting what people are going to do when hacking them, instead of actually trying to build real cooperation with people or real relationship that it will use later. So that's my input here, and I'm passing on to Jenna.
We have a big group, so I'll try to be quick. I also might be having wonky internet. Let me know if I'm not coming through. But I find my new threshold for all of this is, does Cicero get past the decent intern threshold? And it's not clear to me that it does. On the other hand, I did skip through to the piece about Goff, who is prominent on the Facebook post, and found that he's some kind of world class player, right? So in a nut, his strategy is about being honest and truthful. Mostly, he might withhold something, but he never actually lies. Which brings me to the other piece about, like, in business and in life, is it the case that nice guys finish last versus nice guys finish first? And a theme in our Monday call and our Friday calls is how to accommodate bad actors in their many, many ways. And so what we, I think, have often concluded is bad actors do often win, but with any luck, just temporarily, if the system is able to detect forms of bad faith acting and adjust quickly enough. So hence, we're just rules and more rules. And that in the writings about AI that I've come across, all of it, lots of it seems to be trying to come up with what I see commonly called guardrails. So for every good thing that it does, somebody's going to figure out some bad thing it can do. And can you make a guardrail so they can't do that bad thing anymore? So thus arms race just goes on and on. Other last piece was about this trust, and can nice guys finish first instead of finishing last? that I read the New York Times piece about Sam Altman over the weekend, and one of the pieces that jumped out at me was he played a lot of poker in college instead of going to classes. And that made the point, and I don't think I knew this about him, that he doesn't actually code. You know, he's like he's me. He could be me, a non-coder. And but what he apparently got really good at from poker was just reading other people. And you know, it's like, oh, that's what I'm not very good at, let alone on a call like this, right, where none of us even see each other. So I'll pass it to Grigori now. But those were my, fun to watch this space together with you guys who can actually watch it very well with more granularity than me. Take it away, Grigori.
Okay. I probably failed to explain it to 5-year-old, but when I was looking at the steps, it was hard for me not to think about another game. And I will try to reproduce the steps. First step is to analyze the state on the board and make a prediction of what other players will want to do. Step 2, refine the prediction. Step 3, generate candidate messages. And step 4, filter the nonsense out of those candidate messages. And it immediately reminded me about some ideas that came up when people tried to explain how chess grandmasters think. They basically do the same. They start with analyzing the position on the board. Then they try to figure out the implications of this position. So they're essentially trying to predict the intent of the opponent. Then supposedly they generate candidate moves. And what is interesting, that this idea of candidate moves probably came from, I don't know, mid last century or something like that. And it is based on time factor. You don't have all the time in the world to analyze every potential threat generated by every move. So if you want to generate a short list of candidate moves, you will probably spend too much time analyzing stupid moves. And then you run out of time and panic and perform some stupidity. So this idea of generating candidate moves is probably was borrowed from chess. And step 4, I don't like at all because it's about filtering nonsense. I agree with Naichi that probably filtering nonsense should be done on every step, not after you generated candidates. In chess, every candidate move is supposed to be sound, at least at first glance. Then further calculations, you can calculate several steps ahead, several moves ahead. Can show you that actually it was not so good, but at the first glance it should be pretty sound. So in my view, this shows that it's an implementation of a model that people have in their heads for at least, I don't know, 70 years. And it worked probably very well in chess and Go and other board games. And that's why it was tried in case of diplomacy games. Unfortunately, I never played diplomacy, so I don't know how does it feel, but I kind of can guess that it will work in diplomacy too, because it is a board game after all. As for more real life situations, I believe we need a little bit different model. You cannot model everything with 70 years old, formula derived from chess that actually was debunked recently by some smart grandmasters who observed that actually they don't process information in this particular sequence of steps. So I expect this model to be further refined. And as I said, I would include filtering somewhere earlier, or at least at every step, not at step 4. And I will pass it on to Brian.
Yeah. So this was, I think my two reactions there are two main parts of my reaction center around like the time-bounded nature of games and the idea of skin in the game. I'll get to those, but the explain like I'm 5 is interesting because over the weekend I was playing tic-tac-toe with a 6-year-old, and somebody had taught him the kind of gambits of tic-tac-toe in such a way that as long as he went first, he would either win or there would be a draw. So he was having a real good time not losing until I was like best out of 5 and kind of let him win to get on with life and have dinner and talk to other people and whatever. But it was kind of funny to see a 6-year-old understanding the rules of the game and having enough history playing the game to know all the moves. And every once in a while we would end up in a draw, mostly because he would short circuit and totally miss a move that would have won him the game. But again, that's a time bounded game, and there's no stakes. And I generally feel the same way about chess or diplomacy or any of these other games where yes, there are some like broader tournament things, and the more you play a game, the more history you have, the better models you have around the game. But it doesn't really, you can never get past the fact that it is just a game, and you don't really have no consequences. When you think about an AI system, it's what are the consequences for an AI that lead it to do something or to not do something, other than what its creators have programmed it to do, or hypothetically what it has learned to do itself. I don't really, it's like most humans sort of operate automatically. They don't really even think about strategy, or they might have a bag of tricks that they use in tactical situations, but most of the time there's really no need to negotiate or to reconsider things. Things just kind of happen, and people make choices, and most of the time choices don't have consequences, and every once in a while something will. Generally like the 999 times out of 1,000 nothing bad will happen, and then that one time something bad happens and it completely changes the nature of reality, and everybody else is reacting. And for humans it tends to be like survival, or what advantage can you get, and we humans will extort others or blackmail people or like do bad things in order to make their circumstance better. And I guess that's the real concern with AI is like, will it do bad things, and will it have will there be consequences for humans? So I don't know. I don't really see that changing, but I think that's all I have to say. So I'll pass it up to Ben.
Yeah, so I think this is an interesting sort of way of doing things. I linked the Ziv article. I remember reading this. I think it was last year, and when I saw this prompt, I was like, is this the same thing? And I looked it up, and yes, he publishes it the week after this meta thing comes out. So it's directly related. I was glad I searched it back up again. He clearly knows what he's talking about in terms of the game, which is good because I don't actually know anything about diplomacy or the game. There's just I linked a couple of interesting paragraphs from him. I like the line, in this sense, the hard problem of diplomacy has not yet been touched. But I won't just restate everything in his post. One of the other things I want to talk about on this is that I very much find it interesting and like the idea of having these AIs that are actually like modular, like built out of different sort of things. I think I worry, especially with like Chat GPT-4 or whatever. People have fallen into the idea that, all right, do everything, just bigger language model. But I think that's both obviously untrue in terms of just how the model works itself and as sort of an analogy to all sorts of other things. Your brain, after all, has like specialized portions that are supposed to be focused on different parts. Like there's a speech center, the sight center, or whatever. And yeah, things are all entangled, but it's not just. I think that the success of GPT recently has led to this sort of God is just an infinitely large language model, and I think that's just wrong. And I like the idea of, all right, what we really want is an agent that has these certain abilities. So let's try to create these subsystems that can do that and hook them all together. And I think that's a much better approach than just bigger language model or more data or whatever. So I really like their idea to like, all right, so we have the language model for communicating, we have the strategic engine for trying to grind out the actual game and so on. So that I think is a promising way to approach this. I expect it'll take, I think it's probably harder than a lot of people seem to think. Because these specialized areas have to be both very good at what they do and they have to be sort of invoked in the right way at the right time, which, I suspect is some of the hardest parts of how your brain actually works. But, yeah, that's sort of my thought about this whole CICERO thing. I think I'll move up to Anraj, or if I think one of them you might not be there, you can continue to go up then.
I think it's Anant next. Anuraj is, I think, listen only. Anant?
Thank you. Yeah, I thought I guess I share some of the views that's already been said in terms of the hype that these types of articles tend to contain, and like obviously this was written, at least it feels like the blog post was written to sensationalize the sort of breakthrough that they seem to discuss. I mean, if it was me, I would probably put a couple of asterisks at the top of the title of this blog post and sort of say it's very specific to this game diplomacy and etc. And explain like why probably I think of this CICERO model as like I guess just Ben was describing as like a work of two foundational models. One's like a language model, and another one's like a strategic model, and it's a combination of those two things that's been deployed in the context of the game diplomacy. And I also noted from the article that it was specifically trained on like some 40,000 odd moves and prior gameplays. It sort of made it even possible to even just have a decent seat at the table. And I sort of found it frustrating that I couldn't access the paper that this article seems to link to, but that's another story. Yeah, so it seems like there is the two parts of like planning aware, sort of strategy aware dialogue, and dialogue aware strategy seems to be like sort of the foundational pillar of this model, and this could be useful in a lot of different contexts. But of course, like just as this article stated with this game, it requires further fine tuning for different contexts and to learn different environment and what the best outcome could be for a given sort of strategic game. And specifically in terms of diplomacy, I remember hearing some foreign minister some time ago saying that the sort of to be a good diplomat, you have to be an optimist, and this sort of probably adjacent to what Jenna was saying about diplomacy being like you have to be truth as a strategy for diplomacy. So I'm not sure these things are anywhere close to sort of solving real problems or having a real say in a more serious context other than sort of the research environments that these things seem to be working in. And I always come back to whenever I read a paper on sort of these breakthroughs, I always sort of think about it in terms of like augmenting intelligence, not quite artificial intelligence, in that it could be a really good tool for a diplomat or like a similar person, like a person performing similar functions, and sort of as an assistant that could help in sort of live engagements. But and also interesting, I found a paper that Meta published on calculating bias in these types of large language model. They called it holistic bias, and the interesting thing about that was they had like about 600 different descriptors for different kinds of bias that people tend to sort of showcase. So it seems like a slippery slope to claim that that these things are getting good at solving diplomacy, which could be like a way to invite more attacks on how these intelligent systems are biased in some form or the other. So I don't know how that conflict will get resolved going forward. But yeah, that's me. I'll pass it on to Venkat.
And so I saw this when it first came out, and it bubbled up on my radar again. So I thought this would be a good read after last week's read on GPT-4, because this brings out, I think, an explicitly distributed systems angle. And Mayor was saying I didn't actually prompt about the distributed systems part, but I think all the comments I've heard so far, they're implicitly discussing it. So yeah, the idea of like a system of humans and AIs that basically live at the same level of abstraction and talk the same coordination language, that's, I think, in some ways a holy grail of distributed systems. Like I've heard some version of that as a stated goal for almost 2 decades now. I think I first heard it in like 2005 or 6, when I was on my postdoc research was on a grant that explicitly had that as a goal. It was called Mixed Initiative Systems. And the idea was battlefields with humans and machines kind of like talking at the same level. And I remember even back then, there was a talk by some guys from Intel at a workshop I attended where they were trying to construct a language for humans and machines to talk to each other at the same level of abstraction. And this gets kind of interesting because when you don't do that, if you say machines are going to coordinate through like some protocol of like very formalized, structured message passing systems, and the humans are going to talk in a much more free form thing, you end up naturally partitioning the coordination problem into the part that's well solved with extremely structured communication versus the part that needs more fluid thinking at an agent level. So mixing the two together, I think, leads to not just interesting results, but that's the direction you need to go. So in terms of how to frame this, yeah, I don't think I could explain this to a 5-year-old at all, because it's still not even clear in my head, and I'm personally confused about how to think about it. But reacting to something Ben said, I also agree that scaling is kind of not the right way to get to interesting AIs anymore, and I have a whole line of thought I'm developing on that. But I don't agree that breaking down into composable functions is the way either. In fact, I would say, you want to get as much scale as is necessary, and that may be less than like digesting all this information in the world. So biological creatures seem to get to really functional intelligence with much smaller information sets and training sets. But you don't want to decompose. In fact, you want to actually smash different functions together and mix them in a way that the distinctions start to get blurred. And it's already happening with the more famous AIs. So already initially in the first decade or so, we were thinking separately of text models, image models, and things like recommender systems. Those were the three sort of eigen classes of AIs: text, image, and recommender systems. And increasingly, we are seeing that text and images are getting smashed together. And with I think in the next few years, we'll see recommender systems getting smashed together. So if you go shopping on Amazon, or you go looking for things to read on places like Facebook, increasingly you won't just see links pop up for you to click on, or like things popping up for you to buy, but it'll come along with like text and image that's attuned to your habits. So it might come with like a bit of copywriting that says, hey, you should buy this because blah, blah, blah. And it might show you the kind of image that you personally will respond to most. So personalized advertising that mixes text, image, and recommendations. So I think that's actually the first real world adversarial distributed system that's going to pop up. But when you get to like that kind of what I'm thinking of as generalized multimodality, you have to stop thinking of speech as primarily propositions that are being stated that are either true or false and are communicating information. Speech becomes a much more general thing. And I posted this link in the thread on what's known as speech act theory. So this is a way of looking at speech where speech is actually basically a kind of action. And some of the more formally analyzable things in speech act theory are in a legal context. So for example, when a judge says, I declare the defendant guilty, that's not just a proposition that's true or false. That's actually an action in a world where consequences happen, whereas the judge saying that has binding effects and has other actions that follow because of that. Same thing with verbal contracts. Same thing with a couple saying I do in a marriage ceremony. All these are speech acts because they're more than just propositions. They actually are effectively actions, like picking up an apple or throwing a ball. Those are actions in the physical world with consequences. These are speech acts with similar consequences. So the reason I'm bringing it up this way is this is multimodal in a different sense. So just as like mixing up text, images, and recommendations is multimodality in along one kind of like dimension of varieties of content types, I guess, this is multimodality along another dimension of like, even within a single medium, there are like different aspects to what a natural language sentence means. It could be an assertion, it could be a command, it could be a speech act. And usually when we use language, we mix up all these aspects very freely and deal with sort of the holistic nature of language that does all these things all at once, all the time, right? And you can apply the same kind of logic to like image act theory. Like instead of thinking in terms of speech act theory, there's image act theory, right? And I made that phrase up, but you can think of it as like, in a conversation, you make expressions. And in a digital conversation, you might post emoji, right? And those things convey loose emotions. And that's like those are actions. So if you say something and I make a disgusted face, I'm actually making like a visual action that you will respond to. Like if you offer me like two options for food and say, eat apples or oranges, and I make a disgusted face when you say oranges, that's actually a speech act saying, no, I do not want the orange, and you'll give me the apple instead. So I think once you get to like more and more multimodal, so mixing up types of content media and mixing up various aspects of what those media mean in a situated context, you'll actually get closer and closer to how humans, I think, actually make these decisions. So the four-stage model that a few people have commented on, I think that's actually just a version of the OODA loop. And the OODA loop talks about decision-making and thinking in a very general sense without reference to medium type or aspect of action, right? So OODA is, for those of you who are not familiar, it's the observe, orient, decide, act loop used in military strategy. And it does not specify what you're observing, how you're orienting within what you're observing, what your actual decisions are, or what your actual actions are. So it could be speech, it could be pulling a trigger on a gun, it could be anything. So I think this stuff is actually slowly converging to basically OODA loop based models. And I think that's going to be super interesting. And I think the multimodality along what different, one of the different aspects of a step in any live interaction move mean, that's going to like get deeper and deeper. So we are already talking about text as assertions. Now we're talking about speech as acts. We can talk about speech as decisions. We can talk about speech as intention declarations that other people might believe or not. That's already happening in this diplomacy game. So I think, the results are probably overstated, but it does seem interesting enough and starting to smash together things in the multimodal way that I think is actually the right direction. So I'd expect this to move pretty fast if people start working on it, and we'll get to, I don't know, full OODA loop agents, basically. All right, so that's all I had, and I believe the other two people are on silent, so Stephen and Sachin. So last few minutes, open to anybody else who has final thoughts.
Yeah, I wanted to say something about the distributed side. Let's ignore what they're doing and how they're doing, but they have a computer managing and manipulating multiple humans using messages, and that definitely leads itself to a type of distributed governance using a computer. So imagine if we had an AI like that in the Yak Collective and we wanted to do something, and it would send us messages and, what are people going to do and everything they described in order to get it to happen. So I don't know if you consider that to be a distributed system when it's, centralized by having the AI doing the job of the manager, but from the perspective of humans and also the way the game diplomacy is described, it definitely is distributed. So that's what I have to say.
I think at one point we were discussing actually trying to build a bot like that or finding one bot that might nag people on commitments they've made. So that would actually be interesting. I think already it's possible to build very simple bots that play that kind of generalized social coordination role. Like if somebody says, I will do X next week, just a bot that recognizes that as sort of a commitment declaration, logs it, and then sort of holds that person accountable to it. That would be a very good bot to have on our Discord. All right. So that's it for this week. See you all next week.